Welcome. The main goal today is to learn how to solve equations when we have variables with both sides. So, solve an equation with a variable on each side. Sometimes the variable will appear on each side of an equation. To solve these equations, use the addition and subtraction property of equality to write an equivalent equation with the variable term on one side and the numbers without variables or the constants on the other. So this is where you pile all your variables to one side and all the constants to another. The example. So we have 5 plus 7a equals 4a minus 13. Says subtract 4a from each side. All right, minus 4a. 4a cancels here and here. 7a minus 4a becomes 3a. All right, so now we have 5 plus 3a equals negative 13. Now we're going to subtract 5 from each side. Cancel, cancel. This gives us 3a equals negative 18. Now this is a one step we can solve. From here, divide both sides by 3, and we get a equals 6. So the way to think about this, we have a multi-step here. When we get to this step, it is now a two-step. And then at this one, it is a one-step. So every time we perform a math operation, the idea is to make this a simpler problem. It says check your solution, the original equation, substitute in negative 6. We plug in negative 6 for a. Check to see the results, and it is true. So this is a true statement. Leon says that when you solve 5 plus 7a equals 4a minus 13, you can just combine 7a and 4a because they are like terms. Explain whether he is correct or incorrect. Well, they're on opposite sides, so yes, they can combine, but they will combine in inverse because it has to be balanced. If you want to get that 4a and 7a together, you have to remove it from one side. So that requires doing the opposite. 5 plus 3a equals negative 13. The results of the 2015 Nathan hot dog eating contest are shown. Suppose the men and women winners, Matt and Mickey, decided to compete against each other. To make the competition more interesting, Matt will not start until Mickey has eaten 20 hot dogs. Assume that Matt and Mickey eat hot dogs at a constant rate throughout the competition based on the number of hot dogs eaten in 10 minutes by Matt and Mickey. How many minutes after Matt starts should they have eaten the same number of hot dogs? We want to find the number of minutes M for which Matt and Mickey have eaten the same number of hot dogs. So Matt ate 62 in 10 minutes, which is a rate of 6.2 hot dogs per minute. The number of hot dogs he has eaten M minutes after starting is 6.2 M. Mickey ate 38 hot dogs in 10 minutes, so that's a rate of 3.8 hot dogs per minute. And it's just dividing by 10, which has us move the decimal point. She is given a 20 hot dog head start, so the number of hot dogs she has eaten M minutes after Matt starts will be 3.8 M plus 20. So our equation, we have 6.2 M, and this has to equal 3.8 M plus 20. All right, we have our original equation. Now we're going to subtract 3.8 m from each side. Cancel, cancel. 20 drops down. 6.2 m minus 3.8 m is 2.4 m. From here, we have to divide both sides by 2.4. And let's do a quick calculator grab. Calculator. So 20 divided by 2.4. We get approximately 8.3 infinitely repeating. So after approximately 8.3 minutes, now a minute is 60 seconds, so we can actually cut a minute down into thirds really easily. So that'll be 8 minutes and 20 seconds. Because a third, infinite repeating threes like this, is a third. So that'll be 8 minutes, 20 seconds. He can start. Basketball. Nolan and Victor were two of the top scoring freshman players in a college basketball conference last season. The table shows how many points Nolan and Victor scored and how many games they played last season. The points Nolan and Victor scored this season will be combined with their points from last season to give their total career points. This season, Nolan is hoping to catch up to Victor and have the same number of career points. Assume that Nolan and Victor play every game and score at the same constant rate at last season. So we have to figure out points per game. All right. So for Nolan, we had 750 points over 30 games, which gives us 25 points a game. And that was 750 divided by the number of games. Then we have 782 divided by 34, which gives us 23. We now need to write an equation so they can score the same number of points. So we have 23. And then we have their current points. So Nolan has 750 because that's where they're starting at. And Victor has 782. All right, so we have their points they started with and the rate that they're going to be scoring points, and now we need to solve. It says based on equation A, how many games this season. So what we have to do is I'm going to subtract 750 from both sides. While simultaneously, where's my blue? Oh no. Subtracting 23p. 23's cancel, 750's cancel, 25p minus 23 is 2p equals 700 and 700 cancel. This is going to give us 32. Divide by 2, we get p equals 18. All right, so in 18 games, they should have the same career points. Some equation contain grouping symbols. Grouping symbols can include parentheses, brackets, and fraction bars. Right here, fraction bar. So these are grouping symbols, and this is something people need to understand. Grouping symbols include fraction bar, because the numerator and denominator are a group. So simplify the expression on each side, remove any grouping symbols. Again, we're starting with PEMDAS. Use the addition subtraction properties to get the variables on one side, constants on the other, and use multiply and division properties to solve. Some expressions like 2 minus the quantity 11 plus 5 times the quantity p minus 8 contain grouping symbols. To simplify these expressions, work from the inside out by first simplifying the expression with the innermost grouping symbols. So what they mean by that, if you were trying to simplify this, we have 2 minus bracket 11 plus 5 parenthesis p minus 8 parenthesis bracket. Starting at the most inner one to work with is right here. If we expand this out, we get 5p minus 40 From here, 11 and 40 will combine. So negative 40 and positive 11 is going to make 29. So we have 5p minus 29. Now this negative gets distributed. So we have 2 minus 5p, and then a negative make a positive. So this becomes negative 5p plus 31. Example 3. So we have our original equation. They use the distribution property here to get 7n, and right here to get minus 7. So negative 2 times 3 is negative 6. Negative 2 times n is negative 2n. From here, it says we're going to add 2n to both sides. That's going to eliminate it from the right. Cancel, cancel. 2n and 7n make 9n. Now that we have our variables on the left, we have to move our constant to the right. So we're going to add 7 to both sides. Cancel, cancel. Negative 6 plus 7 is 1. From here, we have to divide both sides by 9. So we get an answer of n equals 1 over 9. All right, it wants us to solve this next one. Our equivalent equation will be 7n minus 14 plus 8 equals 3n minus 12 minus 2. All right, we have some like terms to take care of first. So this is 7n, 2 plus minus 6. We have like terms here, equals 3n minus 14. I'm going to subtract 3n, and moving our constant over, plus 6, plus 6. So down here, 7n minus 3n gives me 4n equals negative 8. 4n equals negative 8. Divide by 4, n equals negative 2. Solving an equation with a fraction. All right, so this is kill the fraction method. We're going to multiply both sides by the denominator to get rid of it. So since the denominator is 4, we multiply both sides by 4. Cancel, cancel. We now have 20y equals 12y plus 16. From here, we are subtracting 12y from each side. cancel, cancel. This gives me 8y equals 16. Dividing both sides by 8, we get y equals 2. And we're going to pause here for now. We'll be back tomorrow with more. Thank